In this video, we are going to discuss about one of the important topic of any data science and machine learning project, which is feature importance. Here, features are those variables which can be used to predict the target variables. Using unnecessary and irrelevant features for our machine learning project can skew the results and degrade the accuracy of machine learning algorithms. So that is the reason we need to find which feature is important for our target variables or for our prediction. In this video, we are going to explain how to generate feature importance plot using scikit-learn from the concept called as tree-based feature importance, permutation importance, and SAP values. In this video, we are going to build a notebook that will build and evaluate a model to predict a data that has been used from the stat models API. So these are all the libraries that we will be using. Here, to use the SAP, we have imported the SAP module. In order to use permutation importance, we have imported it from scikit-learn.inspection. We need to test what is the model that has been built. So for that, we need to split our data for the evaluation. So we have splitted it into training and testing set. We need a matrix since we are dealing with a target variable that is continuous. So we will be using mean squared error. NumPy, Pandas, Plotly is all those libraries here that are essential for us in order to work with cleaning and munging of data. And finally, we have gradient boosting regressor that is imported here. So it will take some time, just run this module. Now this is the data that we will be using. You can see after we print the info, you can get the column and its information, year, month, day, and everything. Now, if you execute this code and if the data was not read at one time, then you can just rerun. In my case also, it took some time to load. So maybe it will take some time, some movement, maybe 10 to 15 seconds, and it will be imported. Now data frame contains this data of flights, and this is the data that we have imported. You can see all the columns. You can also print the head of it to check what it looks like. I can go down here and data frame head. I can run this, then this is our data that contains 25 columns. That means we have in total 25 features. Now, if we use all of these features, which are right here, the column name. So these column names are nothing but features. Now, if you use all the features, in fact 25 columns for our machine learning model, then some of these are not necessary. Maybe some of these are not that much necessary for our machine learning model. Maybe they are irrelevant, and maybe some of them are so much relevant that they in fact has high correlation with our target variable. So we need to find those things, like we need to find which of these features are important and which of them are not. So for that, we are going to perform a concept called as feature engineering, and inside this feature engineering, we are going to find a feature importance. So let us handle the null values first. So this function will check if inside the data frame we have null values, and some function will give us in each of these columns of our data frame. See here, we have 25 columns. So year is one column, month is another one, day is another column. So we have altogether 25 columns. So in these 25 columns, we are checking what are the total null values in it. So in the year column, we have 0 null values. In the month, we have 0 null values. In the department time, we have 8,255 null values. So we need to remove these null values or handle them before using any machine learning algorithm. So what we are doing here is we are dropping these NA values. So dropping here means we are completely removing it, all of these observation. Since we have total long observation, so it is quite a size also. See here the size of it, and here you can clearly see this is our observation. We have 336,776 total observation, and that is quite high number of observation or rows in our data set. So removing some of these might not have that much effect on our machine learning algorithm. That is what we think, and we remove it in our example. Next, this line of a code is a simple code that takes some values, convert it into the hours, minute, and everything. Because if I show you in our column is a data frame, if I show you the columns information, then in this column information we have something that is called as, let me show you, array time. So this is what I want to show you, ARR time. So I'll copy it, and here in these columns I will access that column, and maybe I want only the head of it. I don't want each and everything. So see here, this is the arrival time. So from this arrival time, what I want is, I want to extract, I want to convert this into hour and minute. So that is what I have done here. So converting arrival time into hour, converting arrival time into minute, converting this attribute, that is schedule arrival hour. So this is all the attribute name that we have inside our data frame. So basically this is just a pre-processing. We are having these values and we are converting it into hours and minute. After running it, now it is time to prepare for our model. So our target is this one. So this is what we are going to predict. So we split our target, and then we have here some of the information that we don't need, and some of those are what we need. So basically these are the information that we remove, and apart from this, whatever remains, that will be our independent variables. So this is what we are going to use to predict y. So x will be used to predict y. So y here is our prediction, and x is our independent variable, and x is what we are going to use to predict y. Now we divide it, we split our data into training and testing set, and 20% will be used for testing and 80% will be used for training. Here you can see it is 0.2. I have just removed this 0. It is 0.2, and random state is given so that the reproducibility of answers will be matched with yours. If you keep this same number onto your project, then your answers and my answers will be same, because the split will take place with the same division of the data, or with the same split. Now we will encode categorical variables, because here we have a categorical variables into our data. If you check our data right here, then you will find that we have some of the data that are categorical data. You can also get the idea from here, that is carrier is a categorical data, and similarly some of these has been hidden, the columns. So we have many categorical data, so we need to encode them, because categorical data are string data in the format. So if the strings data will be used for machine learning model, then they cannot be used, basically they are strings, so we need to convert them into the numerical values. So that is the process called as encoding categorical variables. And we have used here leave one out encoder technique, as it creates a single column for each categorical variable instead of creating a column for each level of categorical variable like one hot encoding. So basically we are using leave one out encoder, and we will discuss about these techniques in the upcoming video. Just remember, this is a process that will convert the categorical variables into the numerical variables so that we can use them for our machine learning model. Now finally we have the machine learning model here, gradient boosting regressor, with a learning rate and the depth size and everything. The estimator here is basically the number of trees that you want to build, and iteration, and we use this to fit the model and find the root mean square error. So now if you run this code, it will take a lot of time. You can get relaxed, because this is going to iterate too much of time, and after it converts you are going to get this value. Now finally it is time to use this model for the feature importance. So our model is this model, gradient boosting regressor. So using this model we can extract the feature importance attribute. Now after it we are sorting those feature importance, and after that this line of code is only for plotting this information. Now according to gradient boosting regressor, what it found was origin attribute is the most important feature, then arrival hour, then this scheduled department hour and department hour, and scheduled arrived hour. Then after all of these importance that we thought previously, they are not that much important. The origin was in fact the most important feature while predicting the arrival time. So if you go here at the top, then I need to find that values, which is origin. So origin is the column that is the most important one. So I can just extract the values. So from data frame, if I extract origin, I don't want to print all of them, rather I'll just get the head of it. So here this is the origin. So origin here is a categorical variable. In fact, this origin represents the source airport. This is the code of each of the airport. So that is an important one. And now you can see these are the attributes or feature that is important, and it is plotted using Gini importance or Gini importance, whatever you want to call it. It is a Gini importance, and basically we use this for our tree based algorithm, basically for the decision tree, and that is what gradient boosting regressor use. It is going to create the trees, and the next trees will be built by minimizing the error of the previous trees. And now we can find the importance attribute right here. We can also use other techniques like permutation importance. For the same model, we have used the same model for the permutation importance, and according to the permutation importance, the most used attribute is arrival hour attribute, and rest of them are used here. The day, destination are least used model and they are not that important. That is what permutation importance has predicted. And similarly, we have a SAP values. Here we instantiate our model. The model is the same model that we have used here for our gradient boosting regression. We use the same model. We extract the SAP values through this SAP importance and we plot it right here. So this code up till here is basically instantiating the SAP values, calculating it and finding the importance and sorting the importance according to the descending order. Then after this much of code is just for the plot of this graph, and according to the SAP importance values, arrival hour and origin is the important one, and that is what permutation importance also predicted. So in this way we can find the important feature and use these features for our predictions and just remove those which are least used, because using all the features might take time for our model building, and even if you use irrelevant features that are not important in the machine learning model, they can degrade our accuracy. So that is the reason you need to find the important features for our machine learning model and only use them and remove all the others that are irrelevant and not important.